Hello this evening. I'm going to talk about several topics tonight, if that's all right. So, just wanted to tell you that. Right, I'm going to just crack on now, if that's all right. Thank you for listening. Thank you. Right, what are the four main components of blood? Plasma, red blood cells, white blood cells, and platelets. So, what are the four main components of blood? Plasma, red blood cells, white blood cells, and platelets. Name two types of white blood cell: phagocyte and lymphocytes. What is the function of the white blood cells? Fight disease. Right, so that's the answer to that one, to fight disease. What do platelets do, and what substance helps them? Clot blood, and it's fibrinogen. Which types of cell have no nucleus? Right, so which type of cell have no nucleus? That's the red blood cell. The red blood cells. Name the substance in red blood cells that combines with oxygen. So that's right. So you've got to name the substance in red blood cells that combines with oxygen, and that's hemoglobin. What is the substance? Name five substances that are dissolved in plasma: urea, hormones, soluble food, carbon dioxide, plasma proteins, salts, hormones. Which type of white blood cell ingests bacteria? That's the phagocytes. Which type of white blood cell produce antibodies? That's the lymphocytes. So I just thought I'd say that to you. Thank you for listening to me. Right, thank you very much for that. Thank you for listening to me. Right, the red blood cells contain a pigment called hemoglobin. Hemoglobin. I've written this word down, and I'm going to show you on my whiteboard. So red blood cells contain a pigment called hemoglobin. At high oxygen concentration levels, oxyhemoglobin is formed. So at high oxygen concentration levels, oxyhemoglobin is formed, and that's OXY hyphen hemoglobin. So I just thought I'd say that to you. Thank you for listening to that. It's OXY and then HAEM hemoglobin. Yeah, sorry. So at high oxygen concentration levels, oxyhemoglobin is formed. So instead of being oxygen, it's just you take the GEN off, and you just have the first bit, which is OXY hemoglobin, is formed. At low oxygen concentration levels, the oxyhemoglobin dissociates into hemoglobin and oxygen. So I just thought I'd say that to you. Thank you for that. Red blood cells carry oxygen from the lungs to the cells. They have a concave shape which gives them a large surface area for absorbing oxygen. So that's right. Red blood cells carry oxygen from the lungs to the cells. They have a concave shape which gives them a large surface area for absorbing oxygen. They have no nucleus, so it's more room to carry oxygen. They contain hemoglobin, which combines reversibly with oxygen in the lungs to become oxyhemoglobin. So I just thought I'd say that to you. Thank you for that. Thanks for listening to me. Right, hemostasis is a process which prevents and stops bleeding. It's the first stage of wound healing, and involving coagulation. So that's to stop the bleeding, and something to do with stopping the bleeding. Coagulation from a liquid to the gel. Platelets are not cells. They're rather small fragments of cells, So if you have a higher than normal number of platelets, can cause unnecessary clotting, and which leads to strokes and heart attacks. So I just thought I'd say that to you. Platelets. The function of the platelet function is to clot the blood so you don't bleed to death when you cut yourself. So I just thought I'd mention that to you. High platelets in the blood is known as thrombocytes. It's something to do with thrombocytes. The high platelets in the blood, something to do with thrombocytes. The protein, the enzyme in the blood plasma, there's something protease protein called thrombin, 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 and it's the principal enzyme. That's right. So hemostasis stops bleeding, and the thrombin is the principal enzyme, and the fibrinogen is converted enzymatically by the thrombin to fibrin, and catalyzes the conversion of fibrinogen to fibrin, and clots, and it stops the bleeding, something like that. So I just thought I'd mention that to you. Sorry about this. Platelets are involved in hemostasis and thrombosis. So I just thought I'd say that to you. Right. Thrombus is a healthy response to injury intended to prevent bleeding. Thrombosis when clots obstruct blood flow through healthy vessels. So I just thought I mentioned that. So thrombus is a healthy response to injury intends to prevent bleeding. Thrombosis when clots obstruct blood flow through healthy vessels, through healthy blood vessels, should I say? I just thought I'd mention that to you. Thank you for listening to me. Right, thank you for this. If the number of platelets in the blood is too low, excessive bleeding can occur. And if the number of platelets in the blood is too high, blood clots can form. Thrombosis may obstruct healthy blood vessels. So I just thought I'd say that to you again. If the number of platelets in the blood, are too low, excessive bleeding can occur. And if the number of platelets in the blood is too high, blood clots can form. Thrombosis may obstruct healthy blood vessels. So I just thought I'd say that to you. Thank you for that. Platelets lack a nucleus. They don't contain nuclear DNA, but they do contain mitochondrial DNA, as well as endoplasmic reticulum fragments. So that's right. So platelets lack a nucleus. They don't contain nuclear DNA, but they do contain mitochondrial DNA, as well as endoplasmic reticulum fragments. I just thought I'd say that to you. The megakaryocytes help form blood clots or slow or stop bleeding. That's right. So the I've written these words down so you can look at them. But megakaryocytes help form blood clots or slow or stop bleeding, help wounds heal. The platelets derive from the megakaryocytes. So the megakaryocytes are the parents of the platelets. To sort of put you in a sort of a, I don't know whether it's a layman's type term, but that's what it says. So platelets derive from the megakaryocytes, That's right. So they're the parents of the platelets. So the megakaryocytes are the parents of the platelets, and the platelets are the children, I suppose, of the megakaryocytes. Thrombocytes are pieces of very large cells in the bone marrow called megakaryocytes. So that's right. Thrombocytes are pieces of very large cells in the bone marrow called megakaryocytes. So I just thought I'd say that to you. Thank you for listening to me there. See, aggregated platelets are high platelets, and then you have to have the anticoagulants. So if you've got that's right. That's right. So if you've got thrombosis, you've got to thin the blood a bit. So I just thought I'd say that to you. And if the blood platelets are low, severe bleeding will occur. So you have the dangers at both ends of the scale, if you know what I mean. So I just thought I'd mention that to you. Right. And what else was I going to say? So the megakaryocytes, that's to do with platelet production. It's to do with platelet production. Erythrocytes, that's red blood cell, and it has no nucleus, and it contains a pigment called hemoglobin, and it transports oxygen and carbon dioxide to and from the lungs. And the megakaryocytes are the main culprits which contribute to they're the culprit. The megakaryocytes are the main culprit which contributes to clot formation inside the arteries and blood vessels, which lead to strokes, which can lead to strokes and heart attacks. So if you have high platelets, that can be dangerous because it can contribute to clot formation and block and obstruct healthy blood vessels. And obviously, low platelets is the other end of the scale where you could bleed to death. So you've got to have them. I suppose you've got to have them somewhere in the middle, not from one. The extreme of low platelets is severe bleeding or bleeding to death, and the high and the other end of the scale. High platelets, thrombocyte production leads. If you've got high platelets, it can lead to blockages and obstruction inside inside arteries and healthy blood vessels. So I just thought I'd say that to you. Thank you for listening to me. Just wanted to say, yeah. So the megakaryocytes are large bone marrow cell with a lobated nucleus. I just thought I'd mention that to you. So megakaryocytes, the sort of definition, if you like, large bone marrow cell responsible for the production of blood thrombocytes or platelets. Another word for platelets, for thrombocytes is platelets. Necessary for normal blood clotting. So if you cut yourself, you don't bleed to death. Thank you for that. Thank you for listening. Thank you for listening to me. And what I'm going to do now, actually, if you don't mind, I'm just going to write some of these words down. Right. I want to just show you some of these long words that you get in biology. Just want to show you that. Thank you. And on this side, I've put this here. Thank you. Thank you very much for looking at that. Thank you. Thanks. Thanks. Lovely. Thank you for listening to me there. Right. What else? Thanks for that. Yeah, so just let's have a little recap here. Red blood cells, their function is to carry oxygen to all the cells of the body. They are especially adapted so that they can do this efficiently. They have no nucleus, more room for oxygen. Their shape is biconcave disc, which gives maximum surface area for absorbing oxygen. They contain a substance called hemoglobin. This is what makes them red. In the lungs, it combines with oxygen to form oxyhemoglobin. In the tissues, it gives up the oxygen to form hemoglobin again. So in the lungs, it has a high concentration of oxygen levels are high. The oxygen concentration levels are high, and in the tissues, it's a lower level of oxygen concentration levels. So I just thought I'd say that to you. Thank you for listening to me there. Thank you. Thanks. Thank you. Thanks very much. Yeah, so we said that thrombus is a healthy response to injury intended to prevent bleeding. So that's right. So obviously when the thrombocyte platelets levels are high, that's when thrombosis can occur, when clots obstruct blood vessels through health. They obstruct healthy blood vessels. They obstruct or block blood flow through healthy blood vessels. So I just thought I'd say that to you. Thank you very much. I'm going to just talk about some more things now, if that's all right. Thank you tonight. Thank you for listening to me. Right. I just might as well talk about this, but whether or not you need to know this is another thing. But control rods absorb excess neutrons. So control rods absorb excess neutrons. And I think it's something to prevent them from being too radioactive. I'm not sure. Is it if you have too many neutrons, it gets unstable and dangerous and very radioactive? It could be that. So, and I think the chemical composition, the elements are boron, B-O-R-O-N, and silver, and cadmium. I think those three elements are involved in control rods. So it absorbs excess neutrons. So I think it's to do with that. So I just thought I'd say that to you. Thank you for that. And I just want to also talk about most electromagnetic radiation from space. So that's right. Most electromagnetic radiation from space is unable to reach the surface of the Earth. And I think that in the stratosphere you've got the ozone layer, and that stops. It protects us. Yeah. So the ozone layer in the stratosphere, right? The ozone layer in the stratosphere is vital to protect us from ultraviolet radiation. So it stops. It's like a barrier. It prevents it from coming down to, the troposphere, or the region we walk in, and so it protects us from reaching the ground, reaching sea level. So I just thought I'd mention that to you. Thank you for listening to me. Thanks. And also, I just wanted to say another thing. When you have atoms, they have the same amount of electrons and protons. But when they become ions, they don't have the same number, as you know, of electrons and protons. And then that makes them become, they act more like conductors. When they're ions, they're more like conductors, and when they're atoms, I suppose they're more like insulators. So when they don't have the same number of electrons and protons, these elements, and they're no longer atoms and they're ions, they become ionized, and they act more like conductors as opposed to insulators. So I just thought I'd say that to you. Thanks for that. Thank you. Another thing I want to just quickly say, if that's all right, I'm just going to write something else down. Right, I'm going to just put here. Right, I'd like you to just look at this, please. Thank you. I've just written that down, as you can see. And it's in nms, nanometers. The units are nanometers. I haven't written them down actually, but the nanometers. And I've got THZ 688 and 688789 for violet, and I've also got THZ for 400 to 484, and that's the frequency. The THZs, I think, is the frequency. So I just wanted you to see that. Thank you. I think the other one's the wavelength, actually. So I just thought, thank you very much. Yeah, THZ 688789 at the top left of the of your screen, and then at the bottom 400 to 484 THZ frequency there. Thank you. Thanks for looking at that. Lovely. Thank you very much. That's the visible light, wavelength and frequency of visible light. So I just thought I'd say that to you. What other things? Right, yeah, I'm going to just write this down for you now, quickly. Right, thank you. If I write this down. Right. Yeah, that's citric acid there. I'd just like you to look at that. That's citric acid. Thank you. And in the bracket it's COOH. Outside the bracket you've got a 3. And written differently, but they come to the same answer. Just wanted you to see that. Thank you. Thanks. My 7, that's my 7 there, with a cross on it, so with the oxygen. Thank you. Thank you very much. Thanks for looking at that. Yeah, now another thing I wanted to say to you. Right, just another thing I wanted to say to you. Radiation can also be said to consist of particles or packets. Right, I'll start again. Radiation can also be said to consist of particles or packets of energy called photons. That's PHOTONS. The difference between light and X-rays, for instance, is the amount of energy that each photon carries. The complete range of radiation is referred to as the electromagnetic spectrum, extending from low energy, long wavelengths, radio waves, to high energy, short wavelength, gamma rays. So I just want to say that again to you. The complete range of radiation is referred to as the electromagnetic spectrum, extending from low energy, long wavelength radio waves to high energy, short wavelength gamma rays. Just wanted to say that to you. Thanks for listening to that. Thank you. And ammonia. I just want to quickly say ammonia, AMMONIA, is the chemical, it's NH3, so it's 1 atom of nitrogen and 3 atoms of hydrogen. It is made, right, it consists of nitrogen and hydrogen, I think. So I just wanted to say that to you. Thanks for that. Thank you for that. Right, I just want to talk about some other things now. Sort of just cover quite a few. I'm trying to cover quite a few topics tonight. But urea is produced in the liver. It's the breakdown product of amino acids. So it's produced in the liver. This urea, UREA, is produced in the liver. The breakdown product of amino acids. Ammonium ions are formed in the breakdown of amino acids. That's right. So ammonium ions are formed in the breakdown of amino acids. Excess ammonium ions is converted to the less toxic urea. That's right. So excess ammonium ions are converted to the less toxic urea. The main process of urea cycle is to eliminate toxic ammonia from the body. So that's right. So the main process of the urea cycle is to eliminate toxic ammonia from the body. So I just thought I'd say that to you. Yeah, so when the urea is not working, let's say urea, it's not working properly, it would mean excess amounts of ammonia in the body. So I just wanted to say that to you. Urea is produced in the liver when excess ammonia. If I start again, urea is produced in the liver when excess amino acids are broken down. Right. So I'll start again. Urea is produced in the liver when excess amino acids are broken down. Urea is the main waste product removed in the urine. Right. So I just want to say, as it is not reabsorbed by the kidneys. So reabsorption involves, this is to do with the kidneys now, reabsorption involves the absorption of molecules, ions and water. Reabsorption of sodium, nutrients, water and other ions. So I just thought I'd say that to you. So selective reabsorption is the process whereby certain molecules, e.g. ions, glucose and amino acids, after being filtered out of the capillaries along with nitrogenous waste products, i.e. urea. So they're not excreted, the glucose, they're kept back in the body, if you like. So I just thought I'd say that to you. So selective reabsorption is the process whereby certain molecules, e.g. ions molecules, that's right, and amino acids, after being filtered out of the capillaries along with nitrogenous waste products, i.e. urea. So I just thought I'd say that to you. Right, yeah. Thank you for that. Thanks. Right, I just want to write something else down for you now. Thanks. Thank you for waiting as I write these down. Thanks for this. Thank you for waiting. Right. Right, if I just show you this here, the top bit is urea, and it's written differently, but it comes to the same. It's written out differently, but it comes to the same answer. And ammonia there, ammonium ions, I suppose. But ammonia is NH3, one atom of nitrogen, three of hydrogen. Just thought I'd show you that. Bracket again, NH2, two outside the bracket. So I just thought, right, thank you for looking at that. Thank you. Thanks. Right, I've just written down some words here. That's my A at the top. A-F-F-E-R-E-N-T. E-F-F-E-R-E-N-T. Just want you to see that. Thank you. That's how that's spelled. Now, yeah, the afferent arterial, I just put is an arterial that brings blood to the glomerulus, and it's larger than the efferent arterial that carries blood away from the glomerulus. So the afferent carries blood that brings blood to the the afferent brings blood to the glomerulus, and the efferent arterial carries blood away from the glomerulus. So I just thought I'd say that to you. Thanks. If I just put here, these are words perhaps you should know what they're. I'm sure you do know how they're written, but it's easy to not know how to spell them, isn't it? I suppose. Anyway, I've written them there. Thank you for that. Lovely, thank you. Arteriole, glomerulus, the glomerulus, ulus. Thank you for that. And while we're on the subject of the kidneys at the moment, I just want to say some more things to you. The nephron is a basic structure of the kidney. So that's right. The nephron, which is Nephron, is the basic structure of the kidney. Separates water, ions, small molecules from the blood. Filters out waste toxins. Like urea, I suppose, amino acid, urea, isn't it? That's right. And returns the needed molecule. So that's right. So the nephron, the basic structure of the kidney, separates water, ions, small molecules from the blood, filters out waste toxins, like urea, I suppose, and returns needed molecules. And I'm going to talk about some more kidney technology jargon here, the various stages of the kidney, I suppose, the technical names for parts of the kidney. Right. So the function of the loop of Henle, which is Henle, is the recovery of water and sodium chloride from urine. So it takes away the water and the sodium chloride from the urine. It sort of just selectively recovers the water and the sodium from the urine. It selectively, recovers water and sodium chloride from the urine. So that's the loop of Henle, Henle. And also I want to write down the distal convoluted tubule. Right, I'll just write this down very quickly for you. Thanks for this. Right, I just put these technical names, these technical terms to do with the kidneys here. Right, thank you for that. Thank you. Yeah, that's an O, that's a U. Yeah, thank you. So, convoluted tubule and distal, that's distal. And I just want to quickly say, sorry about this, sorry. Yeah, I just want to say that, the distal convoluted tubule, an important role in absorption of many ions and water reabsorption. Something to do with that. Lovely, thank you for that. And while we're on the subject, I just want to quickly talk about the Bowman's capsule. It's a component of the nephron. The first step in filtration. So I just thought I'd say that to you. Thank you for that. Thanks for listening to me there. Thank you. Thanks for this. Thank you. Right, if I just talk about the kidneys are organs of excretion. They remove the waste products, urea, excess waters and ions such as salt. That's right. So the kidneys are organs of excretion. They remove the waste products, urea, excess water and ions such as salt. They first filter the blood, then reabsorb what the body needs. So if they first filter the blood, then reabsorb what the body needs. There are two kidneys situated towards the back of the body, just above the waist. Right, so that's right. There are two kidneys situated towards the back of the body, just above the waist. So I just thought I'd say that to you. Right. What is the kidney's main role? Well, it is cleaning the blood and excretion. Right. So I just thought I'd say that to you. What are the two stages of cleaning the blood? Well, that's ultrafiltration and reabsorption. What is osmoregulation? Regulation of blood water concentration. That's what it is. So that's right. It's regulation of blood water concentration. What hormone controls the amount of water in the blood? So that's right. So what hormone controls the amount of water in the blood? That's ADH. That's the hormone that controls the amount of water in the blood. Which substances are reabsorbed? Well, so which substances are reabsorbed? Glucose, some ions, and some water, and I think sodium is as well. I think it is. And what is urea? Well, I'll tell you that. It's a poisonous substance formed from excess amino acids. So I just thought I'd say that to you. How does the cleaned blood leave the kidneys? Via the renal vein. So I just wanted to say that to you. Right, so ultrafiltration, right, that's right. The blood arrives at the kidney in the renal artery at high pressure and enters the group of capillaries called the glomerulus. This high pressure squeezes water, urea, ions and glucose out of the blood into the Bowman's capsule. Large molecules stay in the blood, right? That's right. So liquid in the nephron contains useful substances like glucose and some ions. So this high pressure squeezes water, urea, ions and glucose out of the blood into the Bowman's capsule. Large molecules stay in the blood. So I just thought I'd say that to you. Yeah, so urea is a poisonous substance produced in the liver from excess amino acids. Adjust ion content. Ions are taken into the body in food and are absorbed into the blood. Any excess ions are removed by the kidneys and in sweat. Water is taken in through food and drink and removed in feces and breath. Excess water is removed in the kidneys and makes up urine. Excess water is also removed in sweat. So I just thought I'd mention that. Thank you for listening to me tonight. Thank you. Thanks. Right. Lovely. Thank you for that. Thanks. Right. I just want to say some other things tonight, actually, to you now. I have a way of doing this. Just sorry about this. Right. If I put in here positive anode, negative cathode, that's like a little mnemonic thing, isn't it? Is it that some, those ways of remembering, trying to remember some stuff? Just trying to have a photographic memory to remember things. Well, I mean, this is one that's been used donkey's years, I think. So anyway, I just wanted to show you that. Now, positive anode, negative cathode, that's what it really stands for. Now, the galvanic cells and voltaic cells. So Alessandro Volta, these are famous, very very learned men who've made a huge difference to us. Their legacy was just incredible. What they achieved when they departed the earth. But Alessandro Volta and Luigi Galvani. So that's right. Alessandro Volta and Luigi Galvani. Sorry about this. So you've got Alessandro Volta and Luigi Galvani or whatever. Something like that. I'm not sure whether I'm spelling the names properly. But anyway, that's these incredible people who made an enormous contribution in the world of science, in the field of science. So I just wanted to, right, and I think it's somewhere along the line. I think I read somewhere that it's the other way around. So it's the negative anode and the positive. So electrolytic cells, right, electrolytic cells applies to that. So electrolytic cells, that is actually right for electrolytic cells. That formula is right for electrolytic cells. But there is another, there's another bit where it's topsy-turvy, and it is, in some situations it's correct to have the positive cathode and the negative anode. So if you put, I know it's going against what you're learning, but that is true. I think it is true. In some situations, there is the negative anode and the positive cathode, and I think it's to do with the voltaic. Just a minute here. Yeah, the galvanic cell and the voltaic cell. This applies to the galvanic cell and the voltaic cell. So, electrolytic cells, it's positive anode, negative cathode, but with the but it's the other way around, I think, with the so it's the positive cathode and the negative anode for the galvanic and voltaic cells. Yeah, sorry. Yeah, I don't know why that is, but so galvanic and voltaic. It's the negative anode and the positive cathode. Thank you for that. Lovely. Thanks. Just wanted to try to get as many topics down. Trying to get as many things down for you for tonight. And also, thanks for this. Thanks for this. And also, another thing I want to talk about tonight. As we know, the exocrine, most of the pancreas is exocrine tissue, right? So most of the pancreas is exocrine tissue. That's right, exocrine tissue. That's right. So that's right. Most of the pancreas is exocrine tissue, but the endocrine function of the pancreas, the area of the endocrine tissue, are called the islets of Langerhans. So the area of the endocrine tissue are called the islets of Langerhans. Endocrine tissue known as islets. Right, that's what it is. Endocrine tissue known as the islets of Langerhans. Langer Hans, Hans. Right, thank you for that. Just wanted to say that to you. They're found in clusters around blood capillaries. The islets of Langerhans secrete hormones directly into the blood. So they're ductless. They don't have ducts, they're ductless. Because I know when I mentioned the other time, exocrine have ducts, but endocrines are ductless. They're made up of two types of cells. The alpha cells secrete a hormone called glucagon, and the beta cells secrete a hormone called insulin. So the alpha cells secrete a hormone called... The alpha cells secrete hormone called glucagon, and the beta cells secrete hormone called insulin. Right, okay. So they're basically that's what it's about. Thank you. Thanks for that. Lovely. So the alpha cells secrete a hormone called that one there, glucagon, glucagon, and the beta cells secrete a hormone called insulin. Thank you for that. Lovely. Thanks. Just wanted to say that to you. And if I just show you this very quickly now. Right, just want to say... Right, very quickly now. I just want to... Yeah, that's glucagon. Just wanted to show that to you. Thank you for that. And, you know, that, thank you. Lovely. I'll just put that again. Thank you. Lovely. Thank you very much. And so alpha cells secrete hormone called GLU-CAGON, and the beta cells secrete a hormone called insulin. Right, that's basically what I want to show you. Right, and if I just do this quickly, show you this very quickly. Just want to write this out to you. So what I want to say to you is, when the glucose concentrations in blood are too high, insulin is secreted by the pancreas. And the liver and muscles convert glucose to glycogen. And the glucose, right, so that's fine. So basically, the glucose concentrations in the blood are too high. Insulin secreted by the pancreas, right? And the liver and muscles convert glucose to glycogen. So again, I just want to quickly just say this to you. Glucose concentrations in the blood are too high. The insulin secreted by the pancreas, liver and muscles convert glucose to glycogen. Now, when the glucose concentrations in the blood are too low, glucose concentration in blood too low, glucagon secreted by pancreas. The glucagon is secreted by the pancreas. And the liver converts glycogen to glucose. So I just wanted to talk to say the regulation of glucose in the blood. And this is the glycogen I wanted to show you. Thank you for looking at that. Lovely. Thank you very much. Right. Thanks. I hope you've enjoyed my talk tonight, and if you like what I'm talking about, could you subscribe to my channel? That'd be very kind if you did. Thank you very much. Thank you. Bye. Thank you. Thank you for listening. It's very kind of you to listen to my talks. Thank you very much. Thank you. Bye.